have an emergency, like, right before you come to class, you find out that, somebody you care about's in the hospital or something's going on, or you get a call from your landlord saying that there's a problem with your apartment, and you have some kind of emergency. That's totally cool. Just tell me I got an emergency, potential emergency, and I'm just gonna have my phone right here, face down. If it buzzes, I'm gonna have to take that call, and that's totally fine. There's no penalty for that. People have lives, people have kids, people have stuff. So I will try to be insanely difficult about that particular thing. Okay. All right. Hey, just earned 5 points. Yay, 5 points. Awesome. In my last class, I did that, and people are writing, and people are wandering in, like, I'm collecting the cards, and like 3 people walk in, and they're like, "What are we doing?" And they're like, "Check in," and they're like, "Can we do it?" I'm like, "No." Class started 5 minutes ago. Where were you? At Holt's Bar. Yes, it is. You were right. But we only have so much time to talk about this stuff, so let's make sure we utilize all of it. Okay. So last time, we talked about different ways of knowing. We talked about the different ways of knowing listed up here. Let's talk about first what we mean by each of those things. So intuition, what's intuition as a way of knowing? What's another way to say intuition? Could be your common sense, could be kind of your gut feeling about what's true. Okay, so that's, when you have intuition about something, you just think so, but you don't really know why you think it. Right? You just think that something's true, even though you're not really sure why. People say, "Well, why do you think that?" I don't know, it's just what I think. Okay? Maybe you don't even have a good reason. It just seems like that's what makes sense. Okay? Tenacity. What's tenacity?
Your gut feeling.
Nope, that's intuition.
Oh, wait, I got you.
Passionate. That's something you know to be true in your heart. You ever known something was true with all your heart? That's a different thing than intuition, right? When you know something's true, like you know, for example, that Jesus died on the cross for your sins, right? That's something you can know in all your heart. Not everybody knows that to be true. That's not true for everybody, but that may be something you hold to be true. You may know with all your heart that you love a particular person. You may know with all your heart that you're going to achieve a certain goal. Okay? You may know with all your heart that you can get through a difficult time. Those are all kinds of knowing tenaciously, having a tenacious belief. That's a belief that you hold true. It's a strength of conviction. It can be a passionate conviction that something is true, even if there's not necessarily hard evidence to back up that belief. Maybe even counter evidence telling you, no, you're not going to make it. No, you can't do this. No, that person doesn't love you, or whatever. And you're just like, nope, I know this is true, and I'm going to keep working as if that were the truth. Okay? What about authority as a way of knowing or believing? What's authority? Okay, well, we're trying not to find a word with its definition. So yes, authority is listening to people with an authoritative position, but what's another way we might describe that?
Someone who's in the know.
Someone who's in the know? Why would they be in the know?
They have
A background.
Education, experience, expertise, right? So authority is going to be an expert for one reason or another about something, right? They might be an expert from the School of Hard Knocks. They might be an expert from Harvard Medical School. They might be an expert from Carnegie Mellon University. Why they're an expert. Or they might be an expert, because they've been a professional ball player and they're now coaching ball. Well, they've been playing, they've been successful, they clearly know what they're doing, whatever. So authority is when someone who is an expert tells us what is true or what to believe, and we acknowledge their authority and thus acknowledge that their belief is true. What's rational discourse again? Rational discourse. Yes. Cornette?
Isn't that when you have to use a certain word, like instead of saying it's been proven or something?
We never prove anything in science, but rational
that's what I'm saying.
discourse.
Like you have to leave it open for someone to go in there and make changes.
It's falsifiability.
What?
That's falsifiability.
Falsifiability. Yeah, I think I would go with that. So let's keep working. We're getting there.
Groupthink.
Well, groupthink's a negative artifact of rational discourse, but what is rational? Well, obviously we need to have a discussion, right? And a discussion among people, usually, yeah. But we're typically having a group discussion, and very often we're talking about groups of people who have some degree of authority on the topic, right? You're going to bring people together who we think should have good enough information to contribute to a conversation like that, and then they can come to a conclusion about what's true. For example, is Pluto a planet? A bunch of people got together and said, not anymore. And that's the truth now. There's not much we can do about it.
Thanks,
And then there's empiricism. What's empiricism as a way of knowing or believing? Experience, right? Your personal experience, what you perceive in the world, what you hear, what you see, what you taste, what you touch, what you smell. That's your personal, direct observation, personal experience with something. Now, these are all different ways that human beings come to believe things, come to know things to be true, or things to be false. Okay? As scientists, what we're going to do is try and take advantage of the strengths of each of these ways of knowing and use those strengths to counterbalance the weaknesses. Because all of these ways of knowing have some weaknesses, but if we use them together, if we use them collectively, we can actually come up with a pretty strong way of deciding what's true that's different from all of those other ways, in that it considers multiple sources of information. So let's talk about now how scientists use each of these ways of knowing. Now, intuition, that's the gut feeling, right? You don't really know why you think something's true, but you just do. Well, scientists use intuition. Scientists are typically reasonably smart people. They're reasonably informed. They may be authority of one kind or another. And so they can have kind of a feeling about why they think something might be true, or what kind of manipulation they might do in an experiment, or what kind of measure they should use. And maybe there's no research showing that that particular choice is the right choice, but they kind of just have a feeling that that's the case. So they can just say, well, this seems what's reasonable to me as a thing to investigate, or this is a possible explanation for why this particular pattern of behavior emerges. So maybe then I could study that as my next big research project. See if I can focus on experiments and kind of explore that. So, they will explore ideas just, because they seem reasonable. That's intuition. They're not really basing it on anything necessarily concrete. It's just that seems like a reasonable next step to take, and okay, I'll do that. Researchers also engage in tenacious belief. Researchers, they will, if they have a theory that they have worked on for a long time, they think they have lots of evidence in favor of that theory, that they've tried to falsify it and not been able to falsify it. They've got evidence from a variety of different domains that the theory is in fact correct. Then they're just going to go ahead and accept that theory as an appropriate explanation for why X is happening and move forward as if that were a truth. They're going to hold on to that pretty tenaciously because of the kind of evidence that they have. Now, as scientists, we always have to do what Darnell was talking about, which is we always have to be willing to recognize that at some point evidence could emerge that demonstrates that our theory is not right anymore. Our theory can't explain the new pattern of results, and we're either going to have to modify our theory or throw it out. So that because theories have to be flexible. We always have to be willing to update our thinking as scientists. But scientists are human, and if they've been really invested in a particular theory, sometimes you'll see a researcher years after other people have dumped a particular theory, and they're like, yeah, nobody really thinks that anymore. But somebody who's invested 30 years of their career in that data, they're going to be like, I'm still going to keep working on it. They just won't give up. And science is a tough thing to do as a career because you basically spend all your time trying to prove that you're wrong because of falsifiability, right? You're always trying to show that what you're thinking isn't right. That's tough on the ego. Because if you're actually good at your job, lots of times you end up designing experiments that show you were wrong. Or other people are spending their time designing experiments trying to show that you're wrong. And they're going to write a paper about it and publish it for everybody that you work with to read. So, you have to have some strength of conviction there to get up every morning and come into the lab and keep doing that, because sometimes doing something completely different sounds really, really good because your ego just can't take it anymore. Now, authority. Obviously, scientists typically are authorities, right? We have certain type of education. We attend certain schools. Some schools are more prestigious than others. Some kinds of degrees are more prestigious than others. And we respect each other's authority. I can't possibly be an expert on everything about visual word recognition. That's a thing I'm really interested in, how people read and how people read in different writing systems. I can't possibly be an expert on everything about that. I can't do all the research myself on every single language written in every single script. I can't do that. I have to trust in the authority of my colleagues across the country and around the world who have specialized in particular languages. I don't read Chinese, but I do read literature written by researchers who specialize in Chinese, because what I'm interested in is Japanese, and the writing systems are related. So I know a lot about Japanese, they know a lot about Chinese, and we read each other's stuff. And so they trust my authority, and I trust their authority. Because I'm going to read their articles because they have lots of time focused on that particular language and see how it can inform my own work. Rational discourse. We talked about lots of researchers or lots of people getting together to talk about and decide what's true. Well, one way to think about peer-reviewed research, right, where I do a research project, I send it out to a journal, the editor of the journal sends it out to other people who have some level of expertise, and they read the article and they decide whether they think my data were reasonably gathered, I've used appropriate measures, my statistics make any sense, if my design of my study was good, if they agree with my interpretation of the findings. And they're going to send back feedback, and so they're going to have a conversation with me through that journal editorial process about whether or not they agree with my interpretation. So that's one level of rational discourse. But also, when that article gets published, it goes out there, it becomes part of a conversation about what's happening in a particular domain of psychology. Or if I go to a conference and I present my work as a poster or I give a talk, I'm basically throwing out my ideas into a domain of rational discourse where other experts in the room, other experts at the conference, are then we're going to talk about whether or not we believe what's going on. I'm going to look at their data, they're going to look at my data. We're going to say, what do we think is happening when it comes to how people read in, say, a script like Chinese compared to something like the English alphabet, and how might that be different based on the data? We'll talk about it and try to come to some conclusion about what we think what's happening, and then proceed with our research from there. Empiricism, right? That's direct observation. This is kind of at the core of scientific observation. We're trying to gather observable data. We're all about behavior. We want to observe behavior as psychologists. As cognitive scientists, we use that information about behavior to try to understand what's happening in the mind, because you can't directly observe the mind. Where's your mind? You know where your brain is, but where's your mind? It's like some cultures believe that your mind is up here. Some cultures believe your mind is in here. Right? Some people believe your mind is here. Some people would say your mind is something that expands beyond you, out into the universe, and you just tap it. Who knows? Because the mind is just an idea, right? It's not a thing that we can directly observe. So we have to gather data about behavior to try and tap into that to understand what's happening in the mind. Now we know the mind is a real thing. I know, for example, that attention is a real thing, even though I can't see attention in any way. because you know that you can pay attention to things, right? And you can ignore things, which basically means not pay attention to them. So you know attention is real, but you can't actually see attention. Sometimes your attention is where you're not even looking. Like when you're walking down a dark street. And what are you doing? You're listening all around you, right? Listening for people moving, listening to hear, feeling a can gets kicked behind you so you could turn around and be ready to respond, right? So sometimes we know attention is there, but what does attention look like? It doesn't look like anything. Right? But I can look at certain behaviors and get information about attention. So scientific thinking involves all of those ways of knowing. And by using all of them, we allow for the possibility, for example, that, so I think I'm an authority on a particular topic. Well, remember, my authority might make me overconfident. So I write up some stuff that's crap. Well, then I send it out for rational discourse, and my colleagues go, Kim, that's crap. Or they send out something and I go, no, Joe, that's crap. We have that conversation, right? Or if I make some particular kinds of observations, well, other people can say, well, I'm going to go try and replicate your study and see if I can get the same results you did, right? I'm going to go see if I can empirically observe the same pattern of results that you empirically observed because I'm not convinced. So we can counteract any weaknesses that might emerge from each one of those ways of knowing, like being too tenacious with a belief when the data says, no. You really need to give up that theory. It's not holding any water anymore. And, 8 out of 10 experts in this field think that theory is a bunch of baloney. And it's time for you to move on at this point because we're not going to publish any more stuff about that theory because we're tired of reading about stuff we think is wrong. Okay? And that happens too. So, as we go through this class, I'd like you to think about what you think and why you think it. When you're reading an article, if you read a particular claim that the author or authors make, and you find yourself agreeing with that claim, why are you agreeing? Or why are you disagreeing? Is it because of intuition, or tenacity, or authority, or rational discourse, or empiricism? Why are you agreeing? Why are you not agreeing? And what are the strengths and weaknesses of that way of thinking? And what might you do to double check to see if your thinking makes sense? Okay? So part of being a good critical thinker in science is meta-thinking, thinking about your thinking, thinking about why you think what you think, and being able to articulate that. Sometimes in the cases of intuition, you can just say, that just doesn't make sense to me. But if you want to persuade somebody else to your way of thinking, you're probably going to have to bring me something else. Then that just doesn't make sense to me. You're like, what about it doesn't make sense? Let's try and flesh that out a little bit more. Explain it. Well, these other people did this other thing, and that makes sense to me because of this and this and this. Okay, so now we're talking about an appeal to this authority. We're talking about some rational discourse. Give me something else to work with. Show me that your point of view makes sense for lots of different reasons. Now, your textbook has an image like this that kind of goes over many of these same ways of thinking, but in a slightly different way. They talk about why we believe certain things and what is the basis of those beliefs. And again, my PowerPoints are available online, so you can download these. You don't have to try and draw this diagram out really fast. It's a little bit crazy. And it's in your text. You can also print it out from the class website. But the basic idea here is that your book organizes why we believe things into kind of these categories. First, you can believe things based on experience. That would be something like empirical evidence, right? Your personal experience. You can believe things based on intuition. You can believe things based on authority. You can believe things based on research. And the research they're dividing into scientific sources, so by scientists for scientists. So that may be more of the authority and rational discourse domain over here. And then they talk about other sources that were designed for non-scientists. And those people may or may not be authorities or may be authorities in different domains. For example, you might have a journalist who knows a lot about a lot of different things, but isn't necessarily a scientist who really understands particular research, but that won't necessarily keep them from writing a magazine article about a particular scientific topic after they've read one thing about it, right? So they're maybe putting themselves forward as an authority on a topic, but it's questionable about whether or not they are. So this is just another way to organize that information. And if you have any specific questions about it after you've looked at that in your book, please let me know and I'd be happy to try and reorganize that for you. One of the things that they point out in this particular chart is they talk about scientific sources, so written by scientists for scientists. And in this class, because we're working on critical thinking, scientific thinking, we are going to focus on these kind of sources. In particular, we're going to be focusing on journal articles, and that's because that represents the most current knowledge in a field about a particular topic. And that being said, for an article to get published in a peer-reviewed journal, because of how long it takes for the research to take place, and then the article gets written, and then it gets sent out, and then it gets reviewed, and then it comes back, and you make changes, you might have to gather more data, send it back out again, get it reviewed again. Sometimes it takes a year or more from the time a study is complete before the data are actually published. So almost everything you read, even in the most current journal articles, is going to be at least a year old. So the research has progressed usually at least a year beyond what's in that article. Sometimes we'll get slightly more current stuff coming out of particular research conferences, big research conferences, national, international research conferences, because that's where people go with the stuff that's in progress. So you'll go present at a conference with stuff before it's been published to get some feedback about it and ideas in order to maybe try to beef up the publication to make it more substantive, because it takes so long to get something out. You want to make sure you get as much out in that article as you can. So stuff from conferences might be more recent, but it's also been vetted less thoroughly, meaning that you can present stuff at conferences, you're bringing that out there for rational discourse, and people can still say, no, that's crap. Once stuff has been published in a reputable peer-reviewed journal, then that means that at least some reasonable group of people says, yeah, we all look at this and we think this makes sense. We want to put this forward as something we can build from. We're going to take this as a truth to some degree. You're going to have to now challenge it at this more formal level in order for us to pull back from thinking that this is good science. So we're going to be focusing on journal articles. And in particular, we're going to be focusing on empirical articles. Those are articles based on direct observations of behavior. So new science, new data, might be related to an existing theory, might be presenting a new theory, but we're going to be focusing on this new stuff, new data, people talking about research they themselves did to test a particular hypothesis under particular conditions. That contrasts with review articles, which tend to be more like summaries, giving us an overview of what lots of different people in a particular domain have been doing with regard to a particular topic. We're not going to use those as sources for any of our work. Now, when we look for these peer-reviewed sources, we're going to look in a particular place too, because we're going to use the same techniques that professional scientists use to find articles that they're interested in. We're going to focus on the use of psychological databases, databases that were designed for scientists to use to find the top tier scientific information upon which to base their own work. These databases include things like Cite, Web of Science, which is really cool. Web of Science lets you find an article that you're interested in, and then it will actually it will give you links to all the articles in the references section, and it will tell you all the articles that have cited the one you like. So you can see where that's fitting in the bigger picture of peer-reviewed science. ERIC is a database that focuses on educational issues, educational psychology, and things happening in the domain of education. PubMed is going to be articles that focus more on biological stuff, neuroscience, those aspects. But PsycInfo, which is the one we're going to learn how to use and we're going to focus on in this class, is the top database for all kinds of psychological peer-reviewed sources. And if you take a look at your syllabus, you'll see that you have homework to go online and look at and complete the Psychology Online Research Tutorial, which is a series of modules put together by Ms. Ida Martinez, who is the psychology librarian here at Georgia State. You're going to want to complete that set of modules online before the next lab, because in the next lab, Ms. Martinez is going to come and do a workshop with you to see if you have any questions about how to do those searches and how to use PsycInfo. Okay, PsycInfo is the port modules are free. They're available online. You can go through them as many times as you want until you think you understand what you need in order to use the PsycInfo database. Then you'll get to go through some more things with Ms. Martinez. Then in lab, we'll do an activity for you to actually try it to see how you do, kind of like a practice to see if you've got the skills you need. And then the following week, you're going to have a quiz where you're going to have to earn points showing us that you know how to use PsycInfo. Okay, so you've got several weeks and several stages to go through to prepare for learning how to use that database. But we're going to focus on that one in this class in particular. But you can also ask her about Web of Science and Eric and PubMed, given your particular area of interest in psychology. It may be, you're really into cognitive neuroscience, you're going to want to know a lot more about PubMed. If you're thinking about getting involved in the education field, then you may want to know more about the ERIC database. She can tell you about all of those databases and how they differ, if at all, from PsycInfo in terms of how you search them. Now, lots of people like Google. We even use Google as a verb, right? Say, I'm going to look something up on the internet. Nobody says, I'm going to go look it up on the internet. They say, I'm going to Google it, right? And just for the record, Windows, nobody, Microsoft, nobody ever says, I'm going to Bing it. Don't you say, that's so dumb. I saw somebody do that on a TV show where they had done they'd done the kind of, they're trying to make it look like, they pay a famous TV show like NCIS or something to have the characters use the particular thing, and I just laugh, and I'm like, yeah, I'm sure NCIS team uses Bing when they use searches, and they literally had like one of their tech guys go, let's just Bing it and see what we find, and I'm like, you did not put that in the script, that's such a loser thing. Oh yeah, Google. Everybody loves Google. You have to look something up. You can even come to me and say, Dr. Darnell, I don't know how to do this citation, and how do I cite a PowerPoint slide in APA style? I'll say, just Google it. Go to Google and type in, how do I cite a PowerPoint slide in APA style? Lo and behold, you actually get a web page called, how to cite a PowerPoint in APA style. So, I mean, even I do that. I love Google. I use Google all the time. And there's a special subdomain of Google called Google Scholar. And scientists do use Google Scholar to go look up some things. There is a lot of interesting stuff up there. You can find profiles of different researchers. You can do a search for a particular researcher and get their Google Scholar profile, find out about all their personal research and find out some more information about them, see kind of the course of their research over time. So it's got lots of good articles and also information about a lot of scholarly books, but it's not organized in the same way. It doesn't allow the same kind of detailed searches that databases like PsycInfo, Web of Science and stuff allow. It doesn't allow you to make the same kind of connections between peer-reviewed research. And there's also stuff posted up there that's not as necessarily as good as the stuff that's posted in the psychological databases. So we do use this for some stuff, but for the purposes of this class, we're going to focus on using PsycInfo to find articles and look things up. And if you look on your syllabus on the very, very back page, you'll see that there are links for 3 articles. These are the 3 main peer-reviewed articles we're going to read and dissect to death in this class. And the links that I've given you on the syllabus are actually links into PsycInfo. So if you pull up an electronic version of this, download it to your computer, you can actually click on those links and it'll take you right into PsycInfo to where you can find PDF versions of these articles. So you can learn different ways to go find things, but I gave you those links just so you can go grab them if you're like, I want to get started, even though the articles are like 5 pages long, they're really short. But if you're one of those gung-ho people who really wants to do it, it's right there. Okay, now, one place students love to go to look up stuff, and I'll be honest, even I go to Wikipedia. I like Wikipedia too. Wikipedia is neat. Like if I'm trying to find, if I don't know about a particular topic, I might just go look there. And when you Google things, Google often takes you right to Wikipedia. In one of my upper division classes, I have students do a project where they have to learn about Dothraki. Do you know what Dothraki is?
Yes.
Yep, the language of the Riders of the Plains from Game of Thrones. I teach a psychology of language course, and one of the options for a project in that class is to actually do a linguistic analysis of Dothraki. It's really awesome, super fun. And you have to learn Dothraki, and you have to teach people in the class Dothraki and how to pronounce Dothraki correctly, and it's really great. And obviously, there is no peer-reviewed scientific research about Dothraki because it's an artificially constructed language made for a super cool TV show. So, but the cool thing about it is that you can actually learn a lot about language by looking at it because it was designed by a professional linguist. So all the principles of actual normal human languages were used to help design that language. Just like Klingon and High Valerian and other kinds of languages that are used in TV shows and movies. I mean, there are linguists, people like me, PhDs in linguistics, who get paid money to make up cool languages. And I'm like, I want that job. When I retire, I'm going to like become a professional constructive language reviewer. Okay, so I like Wikipedia. And I will even send students to use it if that's a reasonable source. But for the purposes of this class, we don't want to use Wikipedia for things because Wikipedia has a lot of people contributing to it. I mean, anybody can. You can, I can, anybody can. But we don't have any way to verify their authority. And we all know on the internet, everybody is really sure they know everything. So there's a whole lot of people with unwarranted authority and overconfidence putting things on Wikipedia. As an example, I gave this last class. An election or so ago, there was a particular former governor of Alaska who was running for the vice presidential slot, who made a claim that the purpose of the Midnight Ride of Paul Revere was to tell the people of Boston to be aware that the British had come to take their guns. Okay? Now, that is not the purpose of the Midnight Ride of Paul Revere. He did not ride through Boston to tell Americans to hide their guns from the British. And yet, there were a number of supporters of this particular candidate who really, really wanted that to be true because they wanted their candidate to be speaking the truth. And so their solution, rather than say, I don't know, expect a vice presidential candidate to actually know American history, was to go to Wikipedia and modify the Paul Revere page so that that was what it said his purpose was. And they actually went in and changed Wikipedia to say that the purpose of his Midnight Ride was to tell Americans to hide their guns from the British. Well, of course, there were people who quite quickly realized this had happened because there were a bunch of people who went to go look at Wikipedia to see what really the truth was, and 1 minute it said one thing, and about 5 minutes later it said, they're coming to take your guns. And so they were like, wait a second, what just happened? And so historians and other experts descended on this page and put it back the way it was and actually put some, evidence-based stuff there as opposed to just what this particular candidate had said in an interview. But anybody can do that at any time on Wikipedia. So there's a lot of good stuff there, and there are a lot of people there who are double-checking, fact-checking, putting sources, verifying things. I go there when I'm trying to find some cool examples or maybe some sources that I don't know about for things, and then I can click through references and see if I like where that stuff is coming from. But Wikipedia is not probably where we want to go for sources in this class either, because we're trying really to focus on those top-tier scientific peer-reviewed sources where we can be really sure of the chain of custody of the information all over. So don't forget to do the PORT tutorial before the next time you have lab, because you will definitely want to have that information and have your questions ready for Ms. Martinez for that workshop. Does anybody have any questions about any of those things before I move on to the next topic? Yes?
I just want to make sure, because I went to the website yesterday, so it's like the 6 videos, we just watch them now.
Yep, go, that's literally what you gotta do in there, like 5 minutes.
Okay.
Yep, it's not gonna take you like 10 million hours. Just go through it, and you can look at the video, and then you can log into Psych Info. If you're on campus, you don't have to have a password. If you are off campus, then you have to log in using your ID and password to show you actually should have access to Georgia State resources. But you can log in from home and check it out, and then try, apply, see if you can do the things that she describes in the videos. Yep, that's what you gotta do. All right. So now I want to talk about scientific claims. And we're going to spend a lot of time in this class talking about what makes something a reasonable scientific claim. We're going to be reading articles and trying to decide if the claims being made by the authors are reasonable and whether or not we believe them. Before I jump into that discussion, though, of how we're going to do that kind of evaluation, I want to make sure we're on the same page with regard to specific terms. First and foremost, I want to make sure we're clear on the difference between a variable and a constant. A variable, most simply, is something that has multiple values, at least 2. So, for example, some people, when they talk about sex as a variable, they talk about it having 2 manifestations, male and female. That's a really simple way to think about it. When you talk about breeds of dog, you can have lots of different manifestations. You could have English Bulldog, German Shepherd, Chihuahua, Great Dane. Like, these are all different manifestations of the variable bulldog or of dog breed. So a variable has to have at least 2 different manifestations or 2 different levels in the world, high and low, 0 and 1. At the very least, right? You have to have at least 2 different manifestations of that thing in the world for it to be a variable. Put even more simply, it has to vary. That's different than a constant, which does not vary. Constant only has 1 manifestation in the world, at least with regard to your particular study. So if I'm doing a study where I'm looking at animal breeds or dog breeds, I can say, all right, I'm going to have bulldogs, English bulldogs, and Great Danes, and Chihuahuas. And those are going to be the manifestations of this variable in my study. Okay? Now, there are other manifestations. You're not using them, but it's a variable because you've got 3 different breeds in your study. Now, if you decide that for the purposes of your study, you want to simplify something for whatever reason, you don't want to have male and females of all of those breeds because you can't get enough of each kind or whatever. And you say, I'm just going to focus on male. So all of the dogs in the study are going to be male. Well, then what you've done is you've taken that idea of sex and you've turned it into a constant. Okay? Because if every dog in your study is male, it's not varying. It's not manifesting in different ways in your study. In your experiment, it's a constant. You're holding it constant. You're making sure that it doesn't vary on purpose because you're trying to keep that particular thing from causing any unnecessary influence to your work. And when we talk about variables, we can talk about independent variables and dependent variables, measured variables and manipulated variables. We can talk about manipulated variables and subject variables. We talk about lots of different kinds of variables. But first, let's talk about the difference between a measured variable and a manipulated variable. This is really kind of key to scientific study. A measured variable is one where I don't know what the value of the variable is going to be. I might have a scale that I measure something on, like I can say I'm going to measure degrees in terms of Fahrenheit, and I'm going to go outside and find out how many degrees Fahrenheit it is outside. But I don't know what the value is going to be today, tomorrow, this morning, the middle of the day, the evening. I don't know what it's going to be till I go look. I'm going to measure that variable. That's different than when I have a manipulated variable. A manipulated variable is one where I'm basically going to decide what the differences are going to be. So I might decide that I'm going to do an experiment where I give rats different amounts of testosterone in order to see how the amount of testosterone is related to their level of aggression towards other rats in their rat community. And I'm going to say, all right, I'm going to have one group that gets 0 milligrams of testosterone, and another group that's going to get 50 milligrams of testosterone, and another group that's going to get 100 milligrams of testosterone. Well, that's a manipulated variable because I can control what those levels are. I control what those manifestations are. I get to pick. And I know that at the beginning. I get to choose it. My study starts off and I can say, here's my variable, my manipulated variable, and here's what its levels are. I chose. Whereas when you talk about a measured variable, you just go out into the world and find out what the values are, because you don't get to choose them. They just are what they are. That's sometimes when we talk about a measured variable, another way that we talk about that is as a dependent variable. Typically, when we measure dependent variables. So if you're looking at something that's measured, where we don't know what the value is until we go look, you're talking about a dependent variable. But when you have a variable that the researcher controls ahead of time, where the researcher gets to decide what the levels are ahead of time, then you're talking about a manipulated variable or an independent variable. So manipulated variables are typically independent variables. Measured variables are typically dependent variables. You can think about that, and it'll help you identify the different types of variables too. Now, not all independent variables are manipulated, but manipulated variables are used as independent variables. Now let's talk about the difference between a conceptual definition and an operational definition of a variable. Now, let's think of something that varies in the world, like memory. Memory, people have different degrees of memory. We know there are different types of memory. There's sensory memory, short-term memory, long-term memory. I can conceptually define short-term memory as a memory that lasts, has a duration of about 30 seconds, unless the person engages in some kind of rehearsal to keep the information fresh. And the capacity of that memory is something like 7 plus or minus 2 units of information. That's a conceptual definition of short-term memory. I'm kind of giving you a sense. It's like what you might find in a textbook. It's like, what is short-term memory? Well, that's your memory for things that last about 30 seconds that you've just been exposed to, and you don't remember it after about 30 seconds unless you rehearse it. So like if someone tells you a phone number and you're trying to punch it into your phone. So you say, they give you a phone number, like, okay, 404-413-6268. And you're like, okay, 404-413-6268. And once you punch it into your phone, what happens? Gone, right? If someone asked you 10 minutes later, what was that phone number? You'd be like, I don't know, but it's in my phone, right? That's its short-term memory. Now, an operational definition of short-term memory is going to be much more specific. It's going to have to do with a particular study. It's how this particular researcher is going to measure or manipulate short-term memory in a particular circumstance for the purpose of testing a particular hypothesis. So I could do a study of short-term memory where I say, in this study, subject short-term memory will be measured in terms of the number of letters they can remember from a list that they are presented on a computer screen for 5 seconds or something like that. So I'm going to show them a list of letters, let them look at it for 5 seconds, the list is going to disappear, and then I'm going to say, write down all the letters you can remember. So there I'm measuring short-term memory. I'm looking at the capacity of short-term memory. Maybe I'm testing that conceptual definition, or that part of the conceptual definition that says short-term memory has a capacity of roughly 7 plus or minus 2 units. Well, if those letters are all random or pretty arbitrarily organized, then people are going to remember roughly 7 plus or minus 2 letters, right? Between 5 and 9 letters from that list. But if those letters make up words, people are going to be able to remember a lot more letters because they'll group them all together and they'll be able to remember more. So what kind of number I get for short-term memory and the capacity of short-term memory is going to depend on how I present the data and how I operationally define short-term memory for the purposes of my study. Other people might operationally define short-term memory in terms of capacity for numbers, or capacity for images, or capacity for musical notes, or capacity for any kind of thing. I just happen to pick letters, because that's what I'm interested in. So an operational definition is the definition of a thing, the definition of a particular variable for the purposes of a particular study. A conceptual definition is going to be a more general definition for the variable that might be kind of an umbrella definition that you might find in a textbook, or that lots of people might be using as a general way to describe the phenomenon, but not for a particular study. When we talk about claims, I mean scientific claims is what we're talking about here, okay? We're talking about something that a scientist is presenting as truth. Something that they are presenting that they want you to believe. And scientists, when they make a claim, they don't just present the claim in isolation. The claim, the statement about what they think is true, or what they think happened, is presented in the context of an argument. So when we talk about the claims that researchers make, or the claims that a particular researcher made in a particular article, I'm not just asking you to tell me what they said, like, this is what we know about the relationship between people's religious views and the usefulness of prayer in counseling. I want to know what evidence do they bring to bear on that statement too. So the claim isn't just the statement, it's also that this evidence that they have is relevant and supportive of that claim. So when we evaluate scientific claims, we don't just evaluate their statement, we evaluate the evidence that they use to back up that statement, to arrive at that statement. It's the whole thing. Does anybody have any questions about any of these terms before I move on? No? Good. All right, so now let's talk about different kinds of claims. If you take a look, if you grab these handouts up here, does anybody not have handouts? Oh, look. So every time you come into class, check and see if there's anything up here, because if I have handouts, I'll set them down here. What I'll do is I will hand these over here to Eric, let Eric take them if he doesn't have them, and then he can pass them back. And we'll send them around the room. Okay, so there's three main kinds of scientific claims that people make in research. Frequency claims, association claims, and causal claims. Did you guys talk about these in 3510?
Yep.
Okay, so you guys know frequency claims are about rates, proportions. And we're just talking about one variable, very straightforward, one measured variable. So one dependent variable, like the proportion of people in the United States who report having experienced depression. Okay, that's a frequency claim. And they're going to offer up evidence in support of that particular claim, and we can evaluate whether or not we believe that. Association claims. These are typically the basis of correlations, right? Or correlational studies. So an association claim is about the relationship between two or more measured variables. Is it true that the more you study, the better your score is on a test? Or is it true that the more time you spend playing video games, the worse your score is going to be on your tests? And these are predictive claims, right? We're trying to say, what do I think is going to happen? What kind of prediction can I make about how strong the relationship is between these different variables? But when we talk about association claims, we're talking about, again, dependent variables and their connection to each other. We're not typically talking about manipulating variables. The big focus of this class is this last kind of claim, causal claims. Okay? Causal claims are those where we have at least one manipulated variable and one measured variable, and we are going to make the claim that changes in the manipulated variable caused changes in the measured variable. So the independent variable, whatever manipulation we did with that, is what made the dependent variable manifest as it did. How much testosterone I injected those rats with influenced how many times they bit their community mates. Okay? Those that got more testosterone bit more often and sooner. Those that got less testosterone bit less often and with less intensity, for example. It was the testosterone that caused the aggression. When we want to establish a causal relationship, we're going to look for three things. First thing we're going to look for is a reasonable, rational correlation between the variables in the study. So does it make sense that there will be a relationship between the amount of testosterone in the bloodstream of an animal and how aggressive that animal is towards others in its community? Does that seem like a reasonable thing? Yeah, there's lots of evidence showing that as testosterone levels increase, aggression also increases. Lots of different studies. So there is a correlation between amount of testosterone and a level of aggression or amount of aggression. So there is a correlation there that makes sense. That's quite different than saying there's a relationship between, for example, how fast you can make a peanut butter and jelly sandwich and how smart you are. I don't really know what the relationship between those two things would be. Because I'm sure that there are people who are very smart who don't make peanut butter and jelly sandwiches very fast. I'm sure there are people who are not very smart who could make them extremely fast and then everything in between. I don't know if there's any connection between those two things. It doesn't really make sense. Next thing we need to have is directionality, which is also known as a time-order relationship. It needs to be the case that the changes in the manipulated variable occur earlier in time than the changes to the measured variable. Okay? So another way to say that is the independent variable has to do something before the dependent variable does anything. If I have a bunch of rats in a colony, and I've already got some rats who are more aggressive than other rats, then there's something going on. I've got different levels of aggression going on,